Hello there. In this video we're going to prove a property about trapezoids, that if I start with just any old trapezoid and I draw in the diagonals, that if one of those diagonals bisects the other one, then that trapezoid has to be a parallelogram. So it certainly doesn't look like it over in this one. I'm going to use this over here to reference everything and mark my givens, that these lines are parallel. And I can choose which one I want to bisect the other one, doesn't really matter. Let's start with A. So AE is congruent to EC, and we'll mark that. So both of these things were given. Now I can start thinking, well, what can I create here? And there are a number of angles that I can get. So I can get those two angles, and that's true by the alternate interior angle theorem. Then I got this line and this line to make that top green angle, and that line, which I already used, and that line to get that bottom green angle. So there's only 1, 2, 3 lines. That's a transversal. Those two are the parallel ones. Now, what other angles do I have? In the middle, we're going to have those pink angles, AED and CED, and that is true by the vertical angle theorem. And that's enough to prove the congruency of the triangles. Remember, the goal is to prove that the larger shape that's going to be made here, ABCD, is a parallelogram, so we're going to have to make some kind of claims about these outer lines there. And to make any kind of claims about those lines, I need triangles. So I'm going to get these two triangles to begin with. So make sure to order them properly. I did ABE, so I started on the outside, went to the green and in, so that's going to be CDE outside to the green and in. And that is true by, what do I have? I have angle, angle, side. So sometimes you get that one. Green angle, purple angle, red side. Green angle, purple angle, red side. Okay, so I have those. There's a lot of ways where we could go from here, but I'm going to be interested in these orange sides now. I know the triangles are congruent, and those are the parts that match up. And then I'm going to go look at the other part of those vertical angles. And this is going to help me get the triangles on the outside here. So I can now talk about like this triangle here and this triangle here. And we have those triangles because we just proved the orange parts and the angles involved. We have that by side angle side. And remember that the whole goal is to show that it's a parallelogram. I already have that those two are parallel, so I want to show that those two are parallel, and to do that we can talk about angles. So we'll continue the proof over on this side. I'm going to have those black angles by corresponding parts of congruent triangles are congruent because of those loop ones. And that is going to give me the two lines now by alternate interior angles, because I got the angles are created by that line, there's the transversal, there's the other line. So those two lines have to be parallel. And we got that one by definition of a parallelogram. Now, if we were allowed to use properties, there's actually a bit of a shortcut in this one. That would have happened as soon as we got these triangles. Maybe we want to mark those two triangles. We got that in the blue step, that we had those two triangles. And we could have said that once we had those triangles, these lengths here, which we knew are parallel, we also know that they are congruent. And then, because these sides are parallel and they're congruent, that's going to mean that it's a parallelogram at properties. But usually we peel back quite a ways. So properties are great. Once you prove them, you can keep using them for other proofs, but when we are doing our tests or quizzes, it's usually good to go back to the definitions. And remember, we could have also done the definitions that those are congruent and those are congruent. Those are pretty interchangeable definitions, but I wouldn't define a parallelogram as a shape where the opposite sides are parallel and congruent. That's just kind of a strange definition. Winds up being a property, and we prove that property. but not a definition, so it wouldn't be my go-to. We want to go back to generally we want to go back to the definitions when we're creating these kinds of proofs. All right, thanks for watching. Character and Scholarship for Life.